Hey guys, we're going to do page 4. So you should have 1, 2, and 3 done. If not, go back and look at those videos, right? And so on question number 4, it says, page 4, we have our standard here. So our standard says students should be able to develop definitions of rotations, reflections, translations in terms of angles, circles, perpendicular lines, parallel lines, and line segments. So what's important there is all of those skills we need. So if you see here, in question number 1, it says a triangle, ABC, is rotated 180 degrees about the origin. What are the coordinates of A prime? They only want the coordinates for A. So if we realize here that we said on our formula sheet, remember we were building our formula sheet here, we said on our formula sheet that they don't give us a lot of formulas. Here's basically how many formulas I have so far. So we notice that just making a quick sketch, if we can't remember these formulas, we can pick a point on a coordinate plane, like the point 3, 1. And then we can rotate that 90. And so we notice, just kind of eyeballing it, that would land us at -1, +3. This allows us to make the conclusion that if a coordinate went from 3, 1 to the coordinate -1, 3, that what happened here is that they switched places. See how the 3 and the 1 switched places, and the sign changed on this first coordinate. Okay? Now, if we were to do that again, same thing, just rotate it another 90 degrees, we would end up over here at -3, -1. We can do the same thing to recognize what would happen to the coordinate. So if instead of rotating it 90, what if we rotated it 2 90s? That would be 180 counterclockwise, because 90 times 2 is 180. So we notice that our coordinate 3, 1 would change to -3, -1, and now we can see this pattern. The coordinate doesn't change places, it merely changes the sign. So if it's positive, now the new coordinate is negative. It would also do the same thing if it was negative and we did this again, rotated it, it would switch from negative to positive. So in a weird way, all I have to do is memorize this rotation rule and do it twice. If we think about X and Y, rotating it once does this. That's our rule. And then if I did that again, swap the spots and change the sign, hold on, here it is. Swap the spots and change the sign of the first, then do that again, swap the spots back and change the sign of the first. See how that would get me this same rule. So you can think of the rule rotating 90 as just rotating it as many times as you need it. So if you need to rotate 90, just do this rule once, and 180, do this tool twice. If you need to rotate 270, do it 3 times. Because 270 is 3 90-degree rotations. Okay, so back to our problem. We notice that if our coordinate for A is 5, 4, which is why I wrote 5, 4, then following this rule, we're going to swap the spots and then swap them again. So we could go straight to the rule for 180-degree rotation as just changing the sign. So a +5 would now be a -5. A +4 would now be a -4. B, 3, 4, would now be -3, -4. And +1, 1 for C would be -1, -1. So what I've done is gone ahead and graphed these, and then allowed myself to be able to see that, like, yes, this does look like it's rotated 180. I can't show you on my iPad, but I also took a piece of paper, put X mark the spot on the piece of patty paper, traced this, and then I rotated it 90 rotated it 90 again, and I noticed through my paper that it did this object mapped on top of it. So that would be our last way to check. Okay, question number 2 says, what is the image under the translation? So we want to remind you that when we translate an image, if they give us the rule, we do exactly what they're asking. So they said take x and subtract 17, then take y and add 2. We know from our coordinate plane that when we go this direction to the right, our x value is going up, and to the left, our x value is going down or negative. As well, our value goes up, that's positive in our y, and when it goes down, that's negative in our y. So we see here they're asking us to move it left 17 and up 2. Okay, so our coordinate 11, negative 4, they're asking us for the x value to subtract 17 and for the y value to add 2. This gives us our coordinate negative 6, negative 2, and we do have a choice there. So we found our answer. Question number 3, it states, what is the rule for translation? So this is what a rule looks like, and that's what we're going to use here. So to do this, you want to write the point you originally have, 3, 2, just like we wrote the point last time. And then here they've given us our answer. So here we had to come up with our answer. Here they've given us our answer. So we're kind of walking back through our steps. How did I get from 3 to 2? So in the x-axis, how would I get from 3 to 2? Notice I went left 1. I subtracted 1. How did I get from 2 to 6? Well, in the y, how would I get from 2 to 6? 2, 3, 4, 5, 6. Yep, I definitely move up 4. So this is left 1 and up 4. This gives us the correct mathematics here. So they've asked, what is the rule? This is how we write the translation rule. Question number 4, it states, the triangle has these vertices and it's rotated 180 clockwise. So we notice 180 clockwise would be, and again, we can make this sketch. We make a sketch and say, if I had the coordinate 3, 1, and I rotated it instead of counterclockwise, if I rotated it clockwise, like how a clock moves, right? Doesn't the clock move this way? Then that would end up at 1, negative 3. And then if I did it again, rotated it 90, I'd end up at the same spot. So notice our translation rule for 180 counterclockwise is the same as 180 clockwise. So we can take our coordinates and follow that rule. So what is the rule? Whatever x is, we're going to change the sign. Whatever y is, we're going to change the sign. So that's what we've done here. A negative 2 would then be a positive 2. A positive 4 would be a negative 4. A positive 2 would be a negative 2. Positive 2, negative 2. 0 doesn't matter if it's positive or negative, it's still just 0. And a negative 2 would be a positive 2. So we've written all the coordinates out for 180 degrees clockwise rotation. And notice I've done it without even graphing it. I could graph it just to make sure. So what did I do in my formula sheet? I added this, so this is the rule for 180 degrees counterclockwise, but also 180 degrees clockwise. I end up in the same spot, so the rule should be the same. All right. Question number 5. Ooh, this one's a big one. So they give us a lot of questions. It says, identify the transformation. So we notice here that the object is pointing the same way. What I mean by that is if I think of this as kind of the head of an arrow, it's pointing here, and here it's pointing that same direction. So we also notice that if I drew a line from H to H prime, Y to Y prime, W to W prime, N to N prime, all those lines are parallel. Notice all of these lines go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. They all have the same slope. So that tells us it's definitely a translation. We recognize that a rotation would change the orientation. Like if I had an arrow pointed at 3 and now it's pointed at 6, we know that's not a translation. That would be a rotation or maybe a reflection over that line, but it's not a translation. So we also know all the travel lines are parallel. We definitely know it's a translation. The other interesting thing now that we've learned about 3D shapes, excuse me, is that this is is one way to draw a 3D shape. So our shape in our front quadrilateral and our back quadrilateral can be connected to create these rectangular faces. So this is actually a prism. So translation is one way to draw prisms. Cool, right? All right, part 2, it says, what is the transformation here? So we noticed the opposite of last time. See how if this was an arrowhead, it's pointed down, and now it's pointed up. So that's how we know it's not translation, because it's not the same orientation. We can also look at the coordinates. Like if we read off coordinate S, we have -3, -3. And if we read coordinate S prime, we have +3, +3. Notice this looks like this 180 rotation that we've got there. We can look at the other coordinates and notice the same pattern emerges. A 0 stays a 0, but a +1 is now a -1 when I write out the coordinates for R and R prime. Same is true for C. A +2 is now a -2. A -2 is now a +2. So this rule applies, and this is our rotation rule. Why isn't it reflection? Well, if it reflected here, S prime, S would have been here. And it's not. It's over there. So I actually think there is an argument for reflection, but it would be more than one. So you could reflect, if S was here, you could flip it over and get here. Flip it over Y, and then flip it over again and get that. Okay, next one, it says, what about this image? So let me kind of erase some of this stuff so you can see. Reflections are traveling by a perpendicular bisector. So we know K and K prime, if we draw a line here, is 4 units long. And this would be the perpendicular bisector cutting this in 2 and that 2. The same holds true for P and P prime, R and R prime. So you might think, oh, well, these are all parallel. Their slope is 0, so that could be translation. But notice the orientation is different. It looks like the first one's pointing to the right, and now the other one's pointing to the left. So the orientation is different. We know it can't be translation. So we realize that since each of these are equal, this length of 2 got cut in half at a 90, this length of 2 got cut in half at a 90, then a reflection is when you have a perpendicular bisector. So the last piece of this is, how can we name this line? And students struggle naming this line. They want to name it Y something because it's parallel to the Y-axis, but notice that it's the opposite of what you might think. So any line that's parallel to the Y-axis would be called X equals something. We can pick some points at random to verify this. So if I picked this point and maybe this one and this one and read off these points, I went -3, +4. I went -3, -3. And I went -3, -4. Notice all of these coordinates are on this line, and all of these coordinates have -3 in the X location. So that's why that line is called X equal -3. All right, last one. Oh, looks like something, maybe I skipped it. Who knows? All right, what happened here? Well, it looks like it flipped over this line. So this is a perpendicular bisector. That's a perpendicular bisector. That's a perpendicular bisector. So let's figure out what that line would be called. If we look at this formula, this line has a slope of rise 1, run 1, rise 1, run 1, rise 1, run 1. Our slope is 1. When we look at our intercept, where does this line cross the y-axis? It crosses it at the origin. So our formula for this line has to be y is equal to 1x plus 0, or just y is equal to 1x, or just y equals x. And that was on my formula sheet from page 1, 2, and 3. So if I look back on my formula sheet, when I reflect over y equals x, I notice that they just swap spots. So we can test this pattern out. Let's take a look. Did the coordinates just swap spots? So when I look at D, D was -4, +4. So if they swap spots, D prime should be at +4, -4. And it is. Let's take a look at U. So U is at -3, -1. If they just swap spots, U prime should be at -1, -3. So U prime is at -1, -3. Yep, this thing definitely reflected over the line y equal x. That's this line right here. Okay? Last one. We found a little snag in our worksheet because we found an answer that was not on there. So it must be, maybe it got cut off. A line segment 0, 0. So we'll draw a line segment 0, 0 to 4, 6. So 4 and 6. If this is our original line segment and reflects over the y-axis, then it's going to make a perpendicular bisector here. So A prime will land here on the left because A is on the right. So that lands the spot at -4, +6. So the new line segment, the red line segment, was flipped over the y-axis. Now it should be the purple line segment. These would be those coordinates of that line segment if it flipped over the y. Thanks for joining us, guys.